How's it going, everyone? Welcome to another video on Enterprise UI development. Eulier Gonzalez here on a new setup. As you can see, that's why after, dedicate a couple months to actually understand what the problem solve. For example, all of these web technologies, including JavaScript and TypeScript, as well as React and Redux, and how you can now write performance React applications, as well as with TypeScript. So what is the value proposition of that? And also with the understanding the fundamentals of front-end system design, which is part of another course, that lead us to, once you know how to build things, you need to know how you can maintain that. And that's the entire reason of this particular course, and especially if you're going to provide this service to other companies, to any clients. So because of that, right? That was a very interesting journey over the couple months. If you were able to actually follow me on that. If you're not, doesn't matter. The whole point of this video is to look at a more practical approach when we are writing or unit testing, which is part of the systems that we need, these foundations that we need when it comes to make our code maintainable over a long period of time with a wide range of contributors in large teams. So because of that, we look at the role of the UI specialist or the lead UI specialist is to not only provide value, solve problems or bug fix, and also is build features. And that's what we need to understand first. But before that, this is now the core structure. This is organized in this way, all right? Where in the introduction we talk about is what are we going to learn in this particular course, what are the more what is the philosophical and then the more realistic and practical approach of what you're going to face in your work, as well as the basic of unit testing, which is part of the system needed when you are going to aim for that goal, which is the maintenance, and also how you can now how you can create now another piece of this system, which is part of the, if you can think of this as a Maslow pyramid, when you have now all at the base, all of the things, or in this case, the systems that you need to place, that you need to put in place. So for example, like testing, as well as build systems, in this particular case with GitHub Action, which is pretty straightforward. You also have other build systems that allow you to do that. So for example, you have Maven from Java projects. And also we need to look at another component, which is this static analysis as part of our system. That's why the entire course is fully TypeScript. So we also need to understand is, what is the subtle difference, or what is the testing spectrum so far with the component testing, accessibility testing and code coverage, right? And then how you're going to, when creating this particular test, the component test, again, this is part of the spectrum that we're going to talk about that, how you can is now mock or put some state in your application. So for example, you don't want, because you don't own certain part of the because you don't own other part of the infrastructure, for example, third-party libraries or things like that, then you need to actually mock that, as well as spine, to actually see if this particular functionality is triggering as expected. That's also is part of this integration testing. Again, something that we're going to talk about that later with playwright, okay, and enforcing standards as a way to now develop the habit, the disciplines when it comes to do all of these code integrations. So the goal of this course is to see how we can build now an infrastructure, the basic installations of the basic installations to for its operation. So this infrastructure, these basic installations on the these basic installations that allows to is maintain the operations for its economy, right? Whether it's economy, when we talk about the economy, the word itself, economy, according to Etymology Online, is the judicious use of resources. So that's exactly what we're going to do, especially when we're going to put all of this particular piece in places. So also, I'm looking at this because it is more wise to, once you have experienced something, still adding new skill sets to that as a way to understand what are the new challenges that you need to face, that you need to deal, and how others, how industry leaders there now have come up and faced that. So because this course is taught by Steve Kinney, head front-end engineer at Temporal, so you can imagine he actually now make this particular course for those who want to dive deep into this, which is essentially something that you are going to do that if you're going to dedicate your time to this. So you better ask yourself, what is the problem that these things actually are solving? That's a good way of how you can start with. And if you don't like the question, then you can start with your own. You know, hey, what are the things that I would like to improve? What are the things that I need to do? Or why and how can I solve my inner problems that I have? But in any case, that's more an introspection aspect of yourself. But what we care about here is, make a quick recap of this introduction and then jump straight forward to writing these unit tests. How can we write our unit tests in a way that we can finally in a way that we can finally get our hands dirty, so we have a more practical approach. So because usually when you are going to have or when you need to find ways to maintain your codes and lay out the infrastructure and this kind of things, this is most of the time because or you inherit an older code bases, or perhaps the code base that you're working, the CEO create now the CEO decide to have now, or decide to create a POC, and then you realize that, oh, that makes sense, that's good, that's great. We need to integrate that to our code base, okay? Or perhaps you need to migrate from older frameworks to whatever hot is this day. This is something that you're gonna see a lot of the time, and a lot of people actually are scary of doing that kind of thing. This is part of the value that we are going to provide, and also when you want to start a new fresh project with the right foot. Okay, so we also define is what are the questions that we need to ask, especially to know what are the problems that we are trying to solve, which is maintaining. So pretty much like if you have a bike or an oven, fridge, there are certain things that you need to know, that you need to know and do, right? So each one of them has different things to do. So for example, in the context of the bike, you have to keep up you need to keep the chains oil, change frequently the oil for the engine, check the lights and brake systems, also the tire. You gotta do all of these particular things. And in the case of a fridge, it's like, hey, this actually plugged right, this is connected, it's actually is cooling the way it's supposed to. Is this clean, right? But again, each one of those things that I would like to call context, you have to do 13 separate. Similar when you hit the gym, all right, or when you try to eat healthy, it's like there are certain things, certain systems that you need to do for a particular goal. So this is pretty much like this. So in terms of maintainability, in the context of software, can we manipulate this? Can we interact with this? Not only can we add stuff, but can we now change something without the fear of breaking something, or update its dependency, or redo a refactor? Okay, are we able to do a refactor without fear, right? Yes, we need to do a refactor. Can we? No. So that's the question that we are solving. That's the problem that we are solving. So hey, can we add code? Can we add and change code confidently enough that we didn't break something? Or can we refactor something without fear or update its dependency? Okay, so this is the 3 questions that we want to solve here. TLDR is that, can we add or change something? Can we update its dependency? Can we do a refactor? Right? So it's important to have the 3 questions as our main guidelines, because so Steve Kinney actually show us in this course is like, what are the components of a well-architectured UI, right? As a well-architecture, the component of a well-architectured UI app. And that is, that you have the testing, that you have the build system, that you have that static analysis, that you separate your business logic from the view layer is another one. That you deploy this, so the deploy infrastructure, and the design process is like, hey, what is the process when we need to add stuff here, okay? Or when we need to change things, what will be the particular process? So for that, the ingredients, according to or based on Steve Kinney experience, he say, the ingredients to have a well-maintainable code base, okay, or a well-architectured UI components, or a code base that is maintainable, okay, that we can add or change code, or do refactors on, update its dependency without fear of breaking something, is that you need to have systems, okay, in place, testing, building system, static analysis, that's the foundation, and then you're going to now develop is the how-to. So first you define is what is that we want to achieve, what is what we want to solve, and then you're going to define is the how. Okay, the how-to. So through code analysis, through code review, through design documents, blueprints, and when you are doing this process, you're going to encounter several things that are recurring, okay, and then you're going to develop with some patterns, so design patterns. So recurring problem that happens is like, hey, this is now the common solution when that happens, and this is quite interesting. I'm gonna make a quick pause here for that, because here we're gonna talk is the design here, design pattern, which is a very interesting website that tells you is what are the most common patterns. And when we talk about design patterns, they are just typical solutions to solve common problems, right? So that you have now structural patterns, behavioral patterns, and yeah, and creational patterns, right? So again, this is problems that happens that occur in this context, in the code, that we have now a typical solution for all of these recurring problems, right? Yeah, there's some benefits of the patterns, as well as there are criticisms of the patterns, because this good practice or these particular patterns actually can lead to more harmful code, because now the code base actually is much more fragile. What I mean by fragile, I mean is because all of this code, so it's like pretty much when you do endogamy, okay, when endogamy, okay, which is you have a very little DNA diversity pool, that then things started to go wrong with the individuals, right? And this is again, I'm just is paraphrasing what you can hear on the culture, you know, when you hear some myths. I will say this is some myth of that, which is this endogamy actually generates a lot of or give birth to a lot of people with certain problems, not only cognitive but also physical ones. So this is exactly what happened here when you use the same tools to solve any problems, right? That they are incapable, they are hard to adapt to new realities. That go beyond the scope. I just want to bring that up because this is something that is now part of the Maslow pyramid, you know, the patterns here. So, and the pattern is that, well, what is the architecture? How this project will look like? What are the state management, you know? You have all of these particular solutions to common problems. State management, and architecture, and abstractions. So because of that, okay, we mentioned here is more like about the infrastructure, economy, and that kind of thing, and what's maintenance, and blah, blah, blah. And then we got is what are the tools that we're gonna use in this particular course, right? So, perfect. So the tools of this course we're gonna look is that it's like React, TypeScript, Vite, Playwright, okay, as well as testing libraries. So we describe now what are the spectrum of testing. Okay, so this particular spectrum is based on the testing system. So you have your unit, you have your end-to-end, then in the middle you have the components and the integrations, right? The unit testing is all about is that this particular function actually work as expected through assertions. And then you have now the end-to-end, which is the same, but instead of a function, we want to check now is a complete functionality, which means the entire user experience, the entire UX workflow. Okay, so on that, because a lot of these things that happen inside of that workflow we don't own. Some piece of that infrastructure we don't own. That's why these kind of tests are very expensive. And they are perhaps doing that in the most critical aspect, for example, logins. And then you have now the integration testing, which is we want to somewhat close to the mimic the A2A testing, where now the A2A is actually testing the applications like real user would do. Hammering that and being hostile to your app. And the integration testing is this kind of middle point as a way to, it can be quite obnoxious, which is testing multiple units, all right? And we're gonna see what actually it means, especially when we are doing with the, when we're integrating that with playwrights, okay? And then you have now these things called component testing, which is now guaranteed that these components actually, in this particular case, UI component actually do what it's supposed to do. But this is very specific to the UI. So a couple terminology here when we need to look at the unit or the testing, okay? So these components render a single component from our application and poke at it. I love it. So this component tests render a single component from our application and poke at it. So this lies somewhere in between our integration tests and unit tests. They are definitely faster than spinning up a browser. It is. So here we're looking at now the unit testing. So your first layer of defense. So the unit testing. So in this particular section, we're going to do is, well, how to set up your unit testing using Vite, and also okay. Okay. So here's what we're going to do. So right. So set up your test environment. Okay. So first is know how can we actually implement this unit testing, right? So by setting our testing environments, previously we have the things called Jest, which is the testing environment that actually it's quite interesting, the history of Jest, because it's actually influenced in other testing libraries or the testing frameworks like GUnit, which is to run this unit test on the Java applications back in the old days, which is something that you really need to do that. Okay, so you can run on that. And the other is the okay. And the other is so once we set up with that with Vite tests, we write some unit tests and look at some advanced techniques when writing this text. I think this is quite interesting to dive deep into this. So once we look at that, we're then going to now in our first foray to build our first, we're going to Yeah, then we're going into our own first foray to start set up our build process for the affirmation tests to check everything work as expected. So first, well, we look at some of the definitions, right? Especially when you set up your testing environment, your testing framework, and then how you can actually is write that particular test. Okay, so first thing first is the assertions. So ideally you would like to be this true and should totally throw an error if not the case. So you have now the assertions, which all of your tests, when you're writing your test, all of them should have is those assertion. The other is tests, which is when you define is the logic. So everything work as expected. Life go on. Okay, life goes on. I love it. Exactly. So is the logic inside of that work as expected? So life goes on. Another way, it throws an error for your test runner to keep track of and tell you about at the end, right? So this is where you define is your logic, where you actually are doing these things. So the test, and then you have now the test suite, which is just a pretentious way to refers to multiple files or multiple tests run and throws an error if things are now if things are not what you like to or what is expected to. So yeah, right. So this particular definition is just as a way to describe is the components body, or when you're writing your test is the anatomy of this test, right? Pretty much when you see a beautiful girl or a nice car, you want to know is what are the different components of that. You know what I mean? So, so yeah, running your tests. Okay, so here we're gonna look at the example here. We actually go into the the anatomy of how you can write your test, which is, well, you can use this eat or test using distinctly. Inside of that, you can actually fail that test. You might wonder when you want to do that. So for example, when you okay, you want to test that for depending on the logic on how you want to test your logic. You can also put a to-do as a way to say, hey, this is the kind of test that I'm going to later on define that, right? And that's quite interesting. That's very, very, very interesting. So let's say you are quite tired, okay? Okay. Let's say you are quite tired, all right? And then let's say you are quite tired. Okay, so you write your code, or you write first your test that fails, and then you write the code. This is part of the test-driven development. That is, well, you first write the test, which is you define is the user story here. So what is the thing that you want to do? Okay. Of course, that test fails, and then you write the necessary code to actually make that happen, to pass that test. Again, the whole point of this is to look at what are the discipline that is required, especially when you're writing your test, and then develop an awareness of what is the things that you're going to do after that. So this is quite interesting. Then we have this the run if or skip if, most likely used on environment when you want is to actually see if you're working with the window objects or not. That's actually quite interesting. But yeah, very narrow specific to that. So because here we're using is V tests, which is this next front-end generation of build tools. V is written in Go. It uses ES build, which is this model bundler reader in Go. So it now is build your application much more faster, and thanks to the people that actually contributed to them. Shout out to them. Shut up, completely shut up. This of course provide more, it provide ESM compatibility, which is something that when you're going to migrate from your applications in Jest or from Jest to Vite, is actually quite simple and quite straightforward. You can also define is all of this particularly tests. Yeah, you can is when you're doing these migrations, you can is now simplify that test by actually migrating from particularly test runner or Webpack all of your tests to actually spinning up that on the to actually spin up that on the, how do you put it, spin up that on the Jesus so you migrate from Jest to, oh my god, did I lose my mind, from Jest to Vite, okay. So instead of actually moving all of his files, you can install VTest because it provides flexible configurations. You can install VTest, provides now the global option, because after all, just using is all of these global variables defining inside of that testing environment. So also VTest is handling browser-like environments, which is quite interesting, very interesting. So you don't need to install a separate tool to actually do that. You can all, because at the end of the day, VTest wants to now integrate all of that, as well as improve the error reporting. So we also run this particular code, and how important is to have now expectations at each one of your tests, because lack of expectations in this context is the test pass. All right. So if there is nothing to test, that's a success test, right? That's a green check. So here we are now. So because we need to actually test what we really care about here in terms of JavaScript, this platform, right? We need to look is at the, hey, if we want to test JavaScript functions, right? Like with any JavaScript course, you need to know is some fundamental concept like, hey, referential transparency as one, as well as referential equality, shallow equality and deep equality, as well as value equality, right? So this referential equality is that, hey, if this particularly object or this particular variable, either identifier, which is an object, has the same reference in memory, all right. So for that we use is the to be, right? It makes a lot of sense. This particular expectation for that. Hey, I want you to know this particular object to be the same for that. And of course, this will fail because you are creating an object on the fly, right? In JavaScript behind the scenes, what it's doing is that once we analyze that, it preserves space in memory, all right? Pretty much like you have now this car box, right? As you can see, this car box, and then you're going to put now in this car box is your notebook. That's right. That's what JavaScript is doing. Then you have now another space in memory, okay? Another card box. And now you want to store is another object, right? And this object will represent is a cell phone, right? I'm not gonna throw that. I'm not gonna throw that. But this is exactly what JavaScript is doing anytime you create an object. And I think this is something that is important to recognize is the basis, because that will lead us to refresh those concepts and understand and revisit those fundamentals, which is essentially what JavaScript is doing. Anytime you are creating is now an object or a variable, but unlike a value, right? Since objects can have the same reference, can point to the same reference, okay? So for example, in this card box, okay, if you want to now add a notebook like this, right? And then you suddenly want to change the content of this notebook, all right? You can say, hey, you know what? Let me actually write what is the password of my computer here. Hey, password. And then JavaScript, what it's doing? Okay, I update that reference. Cool. And then instead of actually creating multiple copies of this, that is of course hard to keep track if one of those copies, okay, it is much more space efficient to say, hey, I'm just going to have this particular reference and all of this object that wants to have access to the notebook, okay, they can now quickly understand that, right? And they're going to update it properly. So that's quite interesting, very, very interesting. So to be actually is doing this referential equality. So we also have is the shallow equality. What it does is to check the list of property and the as a key and the value that are the same with to equal, okay? As you can see here, to equal here, of course, that actually this is this pass, all right? And then we have now the deep equality. So the deep equality is a recursive shallow equality, which means that it's going to look now at the list and the values of those nested properties inside of your objects, okay, if they are the same. Again, to equal actually do that as well. If I am, to be exactly, actually do that for that. So in fact, let me see if I don't lose my mind. Let me actually I quite honestly don't want to use VS Code, but in any case, yeah, let me see if this is bonus exercise, Kanban board. That it has the new status. Bonus exercise solutions, and exercise. Follow me along here. There you got it. You got it here. Wait, what? Okay. So, well, for example, okay, it will throw an arrow. Is this a way of how you can now use that? And here is the greatest hit, right? Here's the greatest hit. when you're gonna use it to equal, to be close, especially to check that for floating points test, to be instance of, to be undefined, to contain, because now we're gonna check if this elements belongs to a list. Okay, that's quite interesting. All right, so assert if the actual value is in an array. Okay, and not only that, it also allows you to check or it works, for example, with class lists, or for example like this, because after all this is returning is an element. You can not only check that, but also you can, for your wrapper document query selector like this of the wrapper to contain the elements, because if you're running a test in a browser-like environment, this assertion also check if class contains in a class list or an element is inside of another one, you know. And this is something quite interesting, quite interesting. Perhaps they have reference to the prototype change for that. That can be one way to do that. So yeah. So yeah. Yeah. So to contain, to throw. Right, to throw an arrow, to use this, you must wrap them into, to throw, to throw arrow here. You must wrap them into a function, okay, that is going to throw that arrow, okay. You must wrap this function that throws that particular arrow, and to match as a way to check if this particular string actually is on a string. All right, it's pretty much like to match a regular expressions for that. The other is to match object. Is like, hey, if I want to make sure that a subset of properties are in an object, you use it to match this. Question is, you can also pass an array of objects. This is useful if you want to check that two arrays match in their numbers of elements, as opposed to array container, which allow for extra elements in the receive array. But again, this is if you want assert if an object matches a subset of property of an object. That's right. Question is that is this, yeah, don't overcomplicate it. Don't overcomplicate things. Like no. Don't overcomplicate things. And by doing that, it's like, hey, don't try to make that nested up. It's like no. And the other is a spec any. Spec any is, for example, the asymmetric matcher, when used with an equality check, will return true only if the value is an instance of the specified constructor. So if the value is an instance of a specified constructor, it will return true when used this equality check. If this is an instance, okay. If this if the value of a property is an instance of a specified constructor. So it's going to take a look at the prototype change on the constructor function prototype change. Useful if you have a value that is generated each time, and you only want to know that it exists with a proper type. Okay. Exactly. Useful if you have a value that is generated each time, and you only want to know that it exists with a proper type. So for this actually something that you're gonna use Okay, if you you don't care about what the value is. You just care about that this value is an instance of. That's interesting. That's interesting. Expect .any. Okay, I don't care what value you are passing to it, but I want that this value is an instance of that. That's interesting. Especially for IDs and that kind of thing. Interesting. Very, very, very interesting. There's some bonus exercise here. Let's get into this. To do should create a board with a title and an array of default status. Okay. As you can see here, this is the title and the board. Where's the shape of this? Okay, this is now a Kanban. That is the title status, which is a string of default statuses, and a URL. All right. Okay, should create a board with a title, an array of default status. So okay. Okay, and then you want to check if that is the default statuses here. Okay. So, because we know that this is this default statuses, okay, which is backlog and reading and all of this. Okay. We can say is now, well, again, this is another part of the advanced techniques. Anytime you're gonna write your test, it is much more meaningful to be repeated than anything else, right? It is much more readable, because that's the whole point of this, you know. Even though they're putting here, right? So when writing test code, repetition is good to keep everything at a glance. So I'm gonna put it here, default statuses. Default statuses. We can actually import that from the default from this. Okay, default statuses. It says like, hey, you can do this. You can say statuses, right? So, so what we're gonna do is to now check if this particular property that is from the statuses, okay, actually contains, or each one of those values, okay, contains exactly. There you got it. Here is telling me here. It's like, hey, we are creating this with the expected values here. Okay. Array containing. Okay. That's right. So what you can say here is to say, hey, you know what? This is the statuses. Okay. Good. Here we can say is, well, let's go into define our expectation here, which is, hey, do we expect that this, let me actually in fact check if this is what we're getting. Expect that this object, okay, expect that the board, the statuses, okay, since this is an array, I expect that okay, I expect that you can use expect.not with this matcher to negate expected value. So when used with an equality check, this asymmetry matcher will return true if the value is an array and contain specified items. Okay. So in this case, what we're gonna do is to, hey, is this board statuses, which is an array, each one of their values to equal, okay, of the statuses, right? So we can get rid of this. I want you to now run this bonus exercise. But I want you to now this spec array containing Fuji. So I expect to equal to statuses. This is one way to do this. It's like as a way to make things simple, right? First thing first, we define is the setup. Okay, we define the setup. The logic, the test logic is already there. And then finally our assertions or expectations. So let's go into now run this and say npnx vtest of the bonus exercise. Yeah, the bonus exercise dot test dot ts, right? And there you got it, right? It say, hey, test file won't skip. Oh, please do this. Exactly, it already passed, right? So it already passed. It say, hey, one pass, okay? So that actually are equals, okay? To expected value. So if we take a look at the bonus exercise example here, we say is this. Exactly. I think that was the particular goal of that. I'm actually drink water because my ears are soothing. Okay. So what you're doing here is that, hey, is this board as it is? I expect now that this new object created, okay, I expect that the board here because it's this, I expect that this board that I create now I'm going to compare with another new object here, which to me is quite silly, but in any case, the must contain is the title, and also contain is the statuses, okay, and also a URL that I don't care about that instance, okay? So I don't care about that, but I just expect that this must be an instance of an stream. You know, of an stream. Just for now, you know. And the statuses, right? B now is, I want you to expect that this array, this must containing an array of default statuses. This array containing, all right, this array containing default statuses, right? It is that. Followed by this, right? So I expect that this new object that I created contain is now this, right? Should create a board with a title, an array of default statuses. So as you can see, that test will pass. If we check out the exercise here, it's pretty much like this. Expect any to be in a string and the title to be in a string. This is as a way, okay, this is interesting. This is if you don't want this is for, okay, this is quite interesting because you're doing some static type analysis. Okay, static analysis. I expect that this any of a string as well, but I miss a comma, and then you got it. This particular test was just to check if at least one of these expectation, I just wanted to check if the type of this property value. I don't care about what is the value that it contains, no, as long as it's this, great, cool. And then you have also add status to a board using add statuses here. Okay, we don't really care else. Yeah, add status to a board using add status. We don't really care what else is in the board status. We just want to verify that it has the new status. Okay. So in this case, we first thing first, we define our setup, then the testing logic. All right. First we remove that and then indicate to vtest to run this test, not as a to-do, so I don't want you to skip that. And then you say, all right, good, because I just want to verify that it has a new status here. It means that it's supposed to, okay. So add status, what it's doing is to push that status to that. So let me check the status there, which is, hey, I expect that the board dot statuses, okay, contain the array. Okay, I expect that the board status, or I expect that the board to equal. So whatever object you create here, or in this case would be is, because I just want to verify the status, exactly. The statuses array, okay. I just want to verify the status like that. I can say, hey, to equal, all right, or the board dot statuses, or in this case, to equal, or to array containing, okay, expect array containing this one. Okay. To this array containing, so I expect that the board statuses expect the array containing Fuji. So I expect that this board to equal, all right, of this, yeah, I expect that the board contains is a title of that, contains a title with the same title, okay. The statuses, All right, the statuses uh, that is spec of any array string okay um, and the URL to be whatever, you know, expect.any string, just like that. So if I run this, of course it'll pass as expected. Let me make a quick pause here. It's a way to see what is the status there. All right, that was quite interesting, you know. It's like, yeah, yeah. It's not that hard. In C, no, you got a real. Now we have a practical. We got a hands-on approach of what we can do, especially when we're writing our tests, and understand what are these particularly components. What is the anatomy when we're writing our tests? So, for example, that you need to define is the setup. First, you need to define is your test. Even if you describe that in a test suite using describe, or as a single test like it or test, you can is put a fail or to do as a way to or define the failing tests that pass this. So for useful when you throw an error, so when you expect that this particularly objects, or when you expect now an error from that. And the other is with the ways of how you can now is write your tests, which is the anatomy of the test. So you have the setup, the logic, and the assertion. So on that topic, then I look at how interesting is for us to say, hey, we were able to still now have a more hands approach, as I mentioned before, right? So we can actually get the feelings of how you make this tool, how you can actually manipulate, how you can touch and interact with this test. And what you're doing, after all, when you are writing your test, right? You want to check that your code work as expected first, and that you can now add or change something with confidence, that confident enough that you won't break anything, or you can migrate or do a refactor with that, right? So that's why initially we look at when you're writing your test, is quite important to know the goal of writing your test. And there's something that I forgot about this. It's like, well, look at what are the specific tools, like pretty much like a doctor will have all of these utils. For example, let's go to check a look. Is the I'm a big fan of Perplexity, but it's like, yeah. Tools, right? Tools for how do you put that thing? Yeah, it's like yeah, tools, doctor utils. Okay, give me a list of doctor utils, please. No, I mean, tools. Stethoscope. All right. Okay. Yeah, stethoscope. Blood pressure monitor. Thermometers. Pulse oximeter. Pulse oximeter. Ophthalmoscope. Otoscope. AKG, AGC machines. Canography machines. Imaging tables. Defibrillators. Surgical equipment. Surgical table. Anesthesia. Emergency equipment. Automated external defibrillator. Oxygen canister and mask. Laboratory equipment, centrifugates, microscopes, general office supplies, examination tables, weighing scales and weight measure, basic first aid supply. Basic first aid supply, interesting. But again, the whole point of these essential tools is pretty much what we're doing here, right? So a doctor and a mechanical has all of these utils, or these tools. So a doctor have the stethoscope, the blood monitor, the blood pressure monitor, the thermometers, the pulse oximeters, ophthalmoscope. Okay, and now a mechanical, right? Okay, or a list of a bike mechanical, right? So have is Allen keys. Allen keys is very interesting. Allen keys, llave Allen, Allen keys or hex wrenches, screwdrivers, wrenches, specialized bicycle tool, wheels and tires. You have, okay, torque wrench, chain breaker tool, chain whip, cassette locking tool, pedal wrench, wheel and tire tools, tire levels, floor pump with gauge, spoke wrench, maintenance and cleaning tool, chaining cleaning kit, degreaser solvents, lubricants, repair stands and workspace, bike repair stands, workbench or counter space. Your additional useful tools, miscellaneous supplies, rag or shop towels, zip ties, anti-seize compound. Mhm. But in any case, the whole idea here is to know what are the different tools that in this specific. So now that on those faculties, so they have now tools that they can identify, and they have now this physical experience, right? So doctors have now the blood pressure monitors or thermometers, stethoscope for auscultation, thermometers, pulse oximeter, otoscope, all right? Yeah, otoscopes, ophthalmoscopes, stethoscope, blood pressure monitors, thermometers, and mechanical has well, Allen keys, screwdrivers, wrench, chain rib, tire level, tire levers, floor pump with gauge, spoke wrench, chain cleaning kit, degreaser solvent, lubricants. You know, it got all of it. Cable cutters, bottom bracket tools, crank puller tool, shock pump. So that's quite interesting. That's very, 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 very interesting. So here, well, our tools for the testing is like what I mentioned before. Okay, so you got is now is well the expectations and the to be and the to be and yeah, the to be and to equal, as well as the to throw error, to be close to be instance of, to be undefined, to contain. Hey, is this element is now is contained on this list, on this sequence, right? To match object and expect any, right? Bonus exercise, well, as to spec.any or spec array containing, object containing, right? Which is, I think, is this. Object containing. Have a URL property that has the title in keyback case. Okay, have a URL property that have the title in keyback case. Okay. Challenge, could you say that I want this to be equal to any object so long it has the URL property that match? Okay, object, expect object containing. It's like, hey, from these objects here, I want not to verify that the value of that is an object that contain is this. So because we wanted to check if this have a URL property that have the title in keyback case. Okay. Okay. So you want to go through the URL, right? So the idea here is to say, hey, I want to expect from this object that I create here to equal, because I want to check is their value of this new object created, okay, that will be contained is the title. Okay, that must be the title. But what I really care about this is not the statuses, right? Statuses. I don't care about the statuses here because I expect any array of a string. It's like I don't really care about I don't really care about the values here. I just really care about you actually have an array of string. But what I want to focus is on the URL, because here this URL, okay, I expect that this contain. Okay, I expect the object containing is a URL. Okay, is a URL. Yeah, is a URL or in this case I expect that this is object containing. We use with an equality check this asymmetric matcher will return true if the value have a similar shape. Exactly. Because would you say that I want this to be equal to any object? Okay, so as long as it has a URL property that matches. Yeah, could you say that I want this to be equal to any object so long as it has a URL property? Oh. Oh. Okay. It's like instead of actually doing this, you can say is that, hey, I expect that this board have an object containing the URL. Okay. I expect that this object contains. I expect that this object contains. This board. I expect that the board to be equal to this object that contains if the URL. Okay. Okay, if the URL that match that particularly that match that. Because you can say is that, hey, URL I expect important thing. I expect that I expect that this value string containing of the keyback to keyback of the title. So you can now run this and it actually passed that. I expect that this URL contains this keyback case title here. So what it's doing is that have a URI property that has a title in keyback case. That's one of the things that is important to write your functions, man, because writing your function is highly testable. Functionality here. Functionality here. Jesus. So you can check this, or I prefer to say, hey, you know what? I prefer to use that keyback function. To keyback case. Which now we actually testing is that function as well as another one. So that's quite interesting. That's very, very interesting. Okay. All right. Good, awesome. All right. So, what's next? What's definitely the next? What's next? Is the async and asymmetric tests.
Let's talk about some of the edge cases around async. We'll kind of live code for a second instead of going into that whole exercise, because we're here. So in this case, right, it does modify.
Right now, you're not going to see what I'm doing because I already received a red flag. So I'm taking notes out of the front-end master course taught by Steve Keeney. So yeah, you're only going to hear is the audio. Yep, let's get into this.
Even though it's technically an asynchronous function, second, it will use this, just to kind of show, I will use this half-done asynchronous function to just talk about some of the edge cases around async. We'll kind of live code for a second instead of going into that whole exercise, because we're here. So in this case, right, it does modify, even though it's technically an async, just to kind of show, I will use this half-done asynchronous function to just talk about some of the edge cases around async. We'll kind of live code for a second instead of going into that whole exercise, because we're here. So in this case, right, it does modify, even though it's technically an asynchronous function, this line does run synchronously. It's mostly the return value. Splice, what does Splice give me these days? It will give me, let's see. Let's actually just have it return the number 4, just to make my point. Cool. And so if I say const return value, and in this case we'll say cool, expect that, and then also expect that its return value to be 4. This one will break because we got a promise.
This won't break here because but we are returning it. Oh, of course it's break because you changed that to async, right?
Does modify, even though it's technically an asynchronous function, this line does run synchronously.
Of course, this will
cool.
break.
And so if I say const, then also expect will break because we got a promise, which hasn't resolved yet.
So yeah, we haven't been
because
resolved
we
yet.
Run this code that returns a promise that hasn't resolved. Next tick of the event loop, it'll finally resolve and we'll have it because there's no network call. It's just
exactly. So it's on the next tick on the So this is not this throw an error because it returns as a promise, so it's not resolved. It's only the next tick that you're going to get that. And by the next tick is when we talk on the browser. It's once now JavaScript analyze all of this code line by line. Then after the end of that file, now the event loop is going to check if you have something on the queue stack, which is when you're adding all of this promise. Okay, if you have several promise there, then it's going to now event loop. We're going to pass the event loop we're gonna pass in the event loop is gonna pass down from the callback queue to the stack queue. So JavaScript is now aware of what it has to do is say, oh, okay, I get something to evaluate here in the call stack. I'm going to actually run that function, okay, evaluate that line by line, and once that is done, remove that from the call stack, right? And this process, especially when the event loop is evaluating its elements on the promise queue or the micro task queue, there's some caveat because the event loop will give priority to solve all of the elements on the micro task queue. So you might is triggering its elements. So you might never reach to the callback queue, right? If you continuously adding elements to the micro task queue. So that's one of the things that to consider. But yeah, that's what is throwing an error. So what we can do is that how can we now handle is asynchronous errors. I'm assuming that they are providing you some sort of methods though to handle that.
A promise. JavaScript technically.
And
so this is now the promise, which is the promise is not for. I have a few different ways that I can deal with this. And we'll talk about...
okay. So here's where it comes the tactics, the techniques here. Okay. Unit testing exercise. So far so good. Async and asymmetric test. Async and asymmetric tests. In plural, please. And asymmetric. No, asymmetric. Exactly. Async and asymmetric tests. Asymmetric tests. Good. Awesome.
Some of the differences between them. One, the most common one is I can just await it and then...
Exactly. There's some techniques, right? So technique for dealing with async operations, right? Technique one. Async, and await. Pretty straightforward.
And we'll pause right there. We'll do other stuff. We'll pause. We'll wait for it. Now return value is in fact 4, and my test passes. Cool.
Will pass where essentially you are not paused. You essentially behind the scenes what you're doing is just to putting that into a different, put it pass down to a micro task, and when that is done, right? What you're doing is that you are resuming, you're back into the function execution to actually is give you the value that you're looking for, right?
The other thing that we can do is I can say that this promise resolves to be 4, right?
Okay, the other is that resolve to be there. Technique 2, right, is expect, okay, resolve.
Really, the time that I would choose to use this is I would probably just await it most of the time. Where I would choose to use this is not necessarily resolves to, but because resolve await just works just fine. Its cousin, reject, is the more interesting one, right? Because like in an async await function, this will like throw an error, and there are ways to check to see if something throws an error, but like then like trying to catch it and make the expectation, but if you didn't make the expectation because you didn't catch the error, then the test passes, right? That's when I would choose to like purposely say, hey, this promise should reject to be this error, this value. Usually with the unhappy path is where I'll use like resolves and rejects. For resolves, I'll usually just use async await. But like trying to do a try catch in your test, that's like a lot of logic. That I can, like, all of a sudden, you never want to get your test to get to the point where you have so much abstraction, you're so clever, that you need tests for your tests, right? Like cue an exhibit meme right now. I heard you like tests, like put tests in your tests, right? You don't want that in your life. So a lot of times being overly simple and repeating yourself versus being clever, because if you get too abstract, who tests the tests, right? So yeah, the only time I would use that one really is if it does in fact throw. And there's an asynchrony folder here that we might visit, which will kind of like show you some of this as well. You can
more useful for trying catching errors.
Really is if it does in fact throw. And there's an asynchrony folder here that we might visit, which will kind of like show you some of this as well. You can expect it to be, you can await, you can reject it in this case. This one will throw. Or it'll just reject it. But you can actually see that it does the thing you want. Also, if you throw inside a promise, that technically rejects it, so on and so forth. But most of the time, I would just await it. And the nice part is, like, you saw when I didn't await it, that was like expected for, received promise. Pretty clear what the issue was, right? Not particularly like versus callbacks where you were just kind of like bewildered. Like, I don't know why it's undefined. Because I didn't put done somewhere in there or something along those lines. So the modern era is great. JavaScript is wonderful. Everything is good.
You know, earlier you mentioned comparing objects where we only cared about a few of the fields. I think we kind of went over this, but how would you go about testing to identify an object based on completed information, just a few of the fields? Only cared about a few of the
I think this is exactly
fields. I think we kind of went over this, but how would you go about testing to identify an object based on completed information, just a few of the fields? Fields. I think we kind of went over this, but how would you go about testing to identify an object based on completed information, just a few of the fields?
The question was basically like, if I only care about a few properties of an object, how can I, like, let's say like I've got some objects that I work with which are like gigantic, right? And maybe I only care about like the type field on it or something. Or like, does it have like these 2 or 3 properties and I don't care about the rest of the ceremony? And then I find myself like bringing in these giant like JSON representations of what I'm expecting only to see like 2 fields that changed. You have 2 options. And it really depends on like what you're going for. One of them is super simple. It's called toMatchObject, and we might as well also talk about its sibling toMatch, which works with strings and regexes, which will make sure that it's like, so if you don't necessarily care about the casing, you could do like a casing-sensitive regex. That's usually really helpful for a lot of things, particularly when doing component testing. But to answer your question, we've got toMatchObject, sensitive regex. That's usually really helpful for a lot of things, particularly when doing component testing. But to answer your question, we've got, might as well also talk about its sibling toMatch, which works with strings and regexes, which will make sure that it's like, so if you don't necessarily care about the casing, you could do like a casing-sensitive regex. That's usually really helpful for a lot of things, particularly when doing component testing. But to answer your question, we've got toMatchObject, which basically takes a subset, right, of that, and like check to see if that subset. So here, if you look at the example in here, we have the John invoice, where the customer in there has got all of the details, and the John details is also roughly the same object, right? So you can see, does the invoice have the customer field, and does that kind of matching just on that? We don't care about the rest. There can be more nuanced ways where we're somewhere in the middle, where maybe we don't care about everything, but we care about some things, right? Like, and for instance, to kind of that half joke that I made earlier. If you find yourself stubbing and mocking your own code, you probably should take a moment, go for a walk, and think about it. But places where that might be the case, which is like if there's any kind of like random ID or UUID generated, right? Like either you have to choose to not care about that, right? That field. Or right, you can mock it or stub it, right? But there's like a middle ground in the middle, which is like completely not caring or not caring in a different way by overriding it, right? But like, okay, the property should be there and it should be a string. Could you do that by hand? Does TypeScript help? Absolutely. But I think that there is a I'm always shocked, and maybe y'all are smarter, maybe you've all seen this before, but I'm always shocked to see how many people don't know about this, so I feel it's worthy to include, is this idea of what we would call asymmetric matching, right? And asymmetric matching, if we actually look at the docs here, we can kind of see it towards the bottom, which are these ones here, which they're not necessarily after you have the value, but they are expect anything, which is there should be a value. Any is a given type here. Let's click on that one. Which is cool. Yeah, the generate ID could be a unique value. It could be random. It could be different every time. So good luck testing that. But if you want to make sure that we get an object where the property has an ID and the value is, as long as it's a number, I'm good. That way you don't have to mock it out. You don't have to do a whole set of weird expectations. You're saying hey, I'm expecting an object that has an ID and any number, right? I don't care. It should be a number, and then maybe you have the rest of the properties. So it's really maybe it's a person, and you care about the first name and last name are what you put in, but that ID is randomly generated, and you don't want that breaking your tests. You could, and you do want to make sure it's a number. Could you write this with enough expectations of expect first name to be blah, expect last name to be blah blah, expect type of ID to be number. Could you do this? But this is a lot easier to just define those properties and have an object the way you thought it should be. And it's got some friends, which is object containing, which is cool. We want to have an array, and for instance, there should be an object that contains name. This is kind of that partial matching that you were asking before with two-match object. There's ways to do this. It definitely should be an array. It definitely should have an object, one object in it, and that object should just contain this property. I don't care about the rest, right? And it lets you kind of be very specific about the things you care about without getting to this tedious because if writing this test is not providing you a lot of value, you know what you're going to do? You're not going to write it at all. Right? Or if it's flaky, you're going to delete it, right? So sometimes it's about getting very specific and very clear on what exactly you care about and what gives you the confidence. When we talk about code coverage, for instance, I don't care about the number. It's do you feel weird when you have to change this? If you wanted to bump a dependency of package.json, do you feel comfortable? That's what we're going for rather than 100% code coverage, you get a trophy. And so writing a test where it's cool, it is checking everything I care, and it's not getting flaky, and it's not getting weird about the stuff I don't care about, and I'm keeping the test, provides more value than either not having the test or because you're going to get tired, right? There's a human nature aspect here. So how do we balance that with reality and begin to deal with it? Cool. Let's just glance at the asymmetric stuff one more time to make sure I didn't miss anything, because with the really great questions, we kind of off-roaded it for a little bit. So let's just kind of look at these real quick. This is an answer pattern. This one passes, even though it should fail.
Yeah, of course.
Right? Because
the absence of a...
it passes before it fails. You know what I mean? We run through the function. This is put on the event loop a second later, but the function's already done, and we move on with our lives when this expectation fails. Right? So that one we could have a promise that resolved. We could fake time even later on. We'll see. There's a whole bunch of ways to deal with this, but know that this is a really great way to make this test fail, and then see if at least the error message roughly looks legit to you, right? Another way to do it is to make sure that there were assertions at some point or another. This will, in this case, this will pass because we got 0 assertions, right? And you get, oh, cool. And this one will purposely fail because it doesn't have any assertions. So in this case, if it is a callback, you can wrap it in a promise that resolves, or there's various things that you can do in this case.
You can wrap it in a promise that resolve.
There's a way in byte test and just to basically move time forward until all scheduled time errors are done. That would also do the trick. We'll see that a little bit later. In the second half of this. But just be aware that, again, you should treat your passing test with a certain amount of suspicion if you have a weird feeling in your stomach that it should have passed. There's nothing worse than you're oh, it worked, and you don't know why. It's worse than it breaking and you don't know why. Cool. But yeah, generally speaking, if you live in a promise-based world like I do, you either just await these results. I don't have to deal with other callbacks in my life.
Oh, it's working.
Modern era, like I said, is wonderful. We're going to do an exercise, and that one is inside of, I believe, Great Expectations. There's some bonuses and some other fun stuff you can see. If you want to see an example of me using the various, so here I'll create a bunch of people. This has a uniquely generated ID. This is kind of a bonus in here, but you can kind of see that I can I can either do it all one by one, or I can be listen, I want the string to start with CS dash, and like that's what my generator should do. I don't actually care about any of the rest of this, but they should be cool. Or I can say like it's just a object containing this. There's lots of options of what you can do here. This is kind of a fake example. But what I want to challenge you with is we've got this little Redux reducer, which will show up various other places before as well. And it's using a UUID. So we could just make sure that the name is the right thing. We have another test to make sure that packed is the right thing for my packing list, right? And just kind of uniquely go and grab each one of those properties and make sure it is what I think it is. However, like, you would have to add an expectation for each one, right? Like one of the nice things that you could do is you could theoretically have a test. And again, this is walking that fine line of like clever, but I think it's clear, where it's like, cool, I have a copy and paste. Some of my best tests are I took a bug report, took the problematic thing, made a failing test and made it pass, right? Like I can be like, hey, here are the properties I don't care about, and just do a spread operator and replace those with these expect dot, any things or anything along those lines. What we want to do is we want to get these tests marked to pass, right? And the tricky part here is that like we want to make sure that like those randomly generated UUIDs are not breaking our test. So we expect that the object to equal that will fail, right? Because one, we don't know the ID yet, and two, it's different every time. So we can't even take the results. So we want, as long as ID is a string, that's fine. But I do want like the rest of the things that I am, and I want it to prefix the right way and stuff along those lines. But like really the important thing is if I add a new item to my packing list that says my iPhone charger, I'm expecting that the thing that got added to my Redux store is my iPhone charger, right? And if the rules of my application are it's false by default, I'm expecting it's false by default. What the ID is, I don't care, right? And so I would play with the like asymmetric matchers in this case and to see like what is one of the more like elegant ways that you can kind of get this off. And again, this is a very simple use case, but like if I think about, I'll show you some like pictures from the app that I work on. I've got like some of these giant JSON blobs, right? A two-match object, or saying like for the parts that can be variable, like time or something along those lines, to uniquely say I don't care about these things, but I do care about everything else is really powerful to having a test suite that you can rely on. Mark. Or something along those lines. I've got like some of these giant JSON blobs, right? A two-match object, or saying like for the parts that can be variable, like time or something along those lines, to uniquely say I don't care about these things, but I do care about everything else is really powerful to having a test suite that you can rely on. Mark.
Is there any real-world example where the set timeout is used and how to identify the init pattern?
We'll do a real-world one later, but I'll just say right now, like toast notifications that are supposed to vanish from the DOM after a certain amount of time, right? Other like banners, like a completed, like anything that's like, particularly when we get to the DOM, things that appear for a little bit and then vanish a loading indicator, right? There's lots of stuff like that where loading indicator like vanishes when the thing is done, but like a toast notification or a banner or some other thing like that might appear for specifically like 5 seconds and then should be off the page. That's when we have to like manipulate time a little bit to like, we don't want to make our test wait, right? Because then like one, you got to get it just right. And then two, now your test is waiting, which makes your test slow. So at which point we'd be like, okay, that banner is only supposed to be there for 5 seconds. Cool, move time forward 5 seconds and verify that's not there. So like there are cases, but like particularly when we get to the more like from the user perspective and less where we're just putting timeouts in our like functions for funsies. Yeah. Or like if you had a function that was supposed to like call a callback and you wanted to verify a unit test, I've done it. Right, I have to look. A lot of times, where I choose to manipulate time is, in cases where I have a function that does relative time, right, from some specific rules. And so, like, it does like the date subtracted from date.now to get the duration. That means my test would change every single time unless I purposely make that first day exactly some amount in the future. So what I'll use is the fake timers in that case to freeze time or set the system clock to a certain current time. And then put in something 6 months back, say like 6 months ago, and stuff along those lines. So rarely, but like it's one of those things which is, do you need it often? No. Do you need it when you need it? Absolutely.
Okay.
There's two things I kind of want to point out. One. we are testing a Redux reducer. It's a real Redux reducer. It's like coming from one of those create React, or no, Redux.
So that'll be all for this video. Take care. Bye-bye.